Hello everyone. Today we'll be looking into GATE 2021 Chemical Engineering question number 47. In a batch drying experiment, a solid with a critical moisture content of 0.2 kilogram water per kilogram dry solid is dried from an initial moisture content of 0.35 kilogram water per kilogram of dry solid to a final moisture content of 0.1 kilogram water per kilogram of dry solid in 5 hours. In the constant rate regime, the rate of drying is 2 kg water per meter square hour. The entire falling rate regime is assumed to be uniformly linear. The equilibrium moisture content is assumed to be 0. The mass of dry solid per unit area is dash kilogram per meter square rounded off to the nearest integer. So this is a question from the drying part from mass transfer operations, and the reference NPTEL lecture can be found in lecture 2 week 3 drying rate of drying for batch dryers in mass transfer operations 2 by Professor Chandan Das, Department of Chemical Engineering, IIT Guwahati. So let us start by drawing our drying curve. So we have the moisture content in the x-axis and the rate of drying in the y-axis, and the straight line represents the constant rate and the sloped line represents the falling rate regime. We have the initial moisture content, critical moisture content and final moisture content as xi, xc and xf respectively, and it is given that initial moisture content xi is 0.35, critical moisture content xc is 0.2 and the final moisture content xf is 0.1. All the moisture contents are in dry basis. So total drying time is the sum of the time required in the constant rate regime plus time in the falling rate regime, and this is given as 5 hours. So 5 is equal to Tc plus Tf. This is a given data. For constant rate regime, Tc is equal to minus W by A into Xc minus Xi by Nc. This is the time required for constant drying rate. Here W is the dry weight of the solid, A is the drying area, Nc is the rate at constant rate regime, and Xc and Xi are the critical and initial moisture contents respectively on dry basis. Similarly, for falling rate, the equation for time is Tf is equal to minus W by A integral of Xc to Xf dx by n. This is the general equation for time in the falling rate regime. Now, let us go to the constant rate regime. Tc is equal to minus W by A Xc minus Xi by n. So given Nc is equal to 2 kilogram per meter square hour. So Tc is equal to minus W by A into substituting the values 0.2 minus 0.35 the whole by 2, and we'll get 0.075 into W by A as the time for constant rate period. Similarly, we can do this for the falling rate period. For falling rate, Tf is equal to minus W by A integral of dx by n from Xc to Xf. So for this, we need to find the equation for the sloped line from the drying curve. So first, let us mark the coordinates of the falling rate regime. So the top point is 0.2, 2 and the bottom point is 0.1, n. And we have to find the equation for n in terms of x. So this is a straight line of the form y is equal to mx plus c. So this c will be 0. So this will be of the form y equal to mx, where y is n, x is the moisture content x, and m is the slope of this line. So for this, we'll get the equation as n is equal to 10x, where 10 is the slope of this sloping line. So we can write n is equal to 10x, and we can substitute this n is equal to 10x in the integral equation. Then we can integrate the following equation from point 1 to point 2. We'll get Tf is equal to minus W by A into 1 by 10 ln 0.1 by 0.2. Because we can simplify this in the following steps, and we'll get the final answer as minus W by A into minus 0.693 by 10. That is W by A into 0.0693. Now, we know that the total time is 5 hours, which is 5 is equal to Tc plus Tf. Now, substitute these equations values for Tc and Tf in this equation. We will get 5 is equal to 0.075 W by A plus 0.0693 W by A. So just add these two terms and rearrange to get W by A, which is 5 by 0.075 plus 0.0693. This W by A is the dry weight of the solid per drying area, and we'll get the final answer as approximately 35 kilogram per meter square. Thank you.